Hi, today we are looking at section 4.4, which is trig functions of any angle. So we're going to talk about a few reminder things. We're going to learn a little bit about reference angles. We are going to determine angles in standard position and how the reference angle and where the reference angle is in each quadrant and how you calculate it from that. And then we're going to work through these examples. So a lot of drawing pictures today and labeling everything we need to label and getting a good foundation for how to use reference angles to determine any trig function. So let's start by reviewing some information that you know about your quadrants. We learned a saying, all students take calculus, and we know that the first letter in each of those words helps us identify in each quadrant which trig functions are positive. So the A stands for all. The A is in quadrant 1. All trig functions, all 6 of them, are positive in the first quadrant. In the second quadrant, we see the word students, which is the second word in our sentence. And when we look at the first letter of the second word, which is S, that stands for sine and its cosecant value. And I just listed the functions here, and I noticed normally you would say like sine theta equals something. I'm just using these to represent the actual trig functions themselves, not problems, okay? Just a shorthand, if you will. And then the third word is take. In the third quadrant, the T stands for tangent and cotangent functions that are going to be positive. And do keep in mind, everything is positive in the first quadrant. So remember we said if tangent is positive in the third quadrant, then technically tangent and cotangent have 2 places on the circle where they can both be positive. So that can afford us 2 solutions. And the last word, calculus, the fourth word is in the fourth quadrant, and the C in calculus stands for cosine and its reciprocal secant. So using this will help you determine, as we're looking at different angles on our graph, where the different functions are positive and where they're negative. Hopefully by now you have a good sense of your inverse and quotient rules. This is one thing that's floating around out there, and as I've always said before, I throw out as many of the things as I find that I kind of like, and use what works for you, lose what doesn't work for you. What sticks and makes sense is where you want to go with that. So this is what they call an identity web. And so the identity can help us with the Pythagorean identity. So I can do sine squared plus cosine squared equals 1. I can do tan squared plus 1 equals secant squared. And so you can do it that way. I can do reciprocals. So like 1 over sine gives me cosecant. I can do 1 over cosecant gives me sine. So there's kind of different things that you can do there to help you. If I do tangent, that's sine over cosine, but if I do cotan, it's cosine over sine. So it's just another way to help you with memorizing the reciprocal and the quotient and the Pythagorean identities. Again, it's not going to offend me if you don't use it. It's just something that has popped up a few times, and I thought it might be helpful to some, so I wanted to include it here. These are the identities that were in the web. These are ones hopefully you already know, and the web is not going to be anything that you really need, but we need to know our quotient identities, our cotangent identities, and our reciprocal identities. These really become important as we talked about some calculator problems. Remember that if I want to put cotangent in the calculator, I have to remember to do 1 over tan theta. So if I don't remember cotan is 1 over tan theta, I'm making some problems for myself in terms of words and work that we're going to do. The terms that I want to go over, and we talked a little bit about this earlier in the chapter. Theta is the angle in standard position, meaning it's going to open from the positive x-axis and it's going to go counterclockwise, and then the angle is going to terminate. So we have the initial side, we have the terminal side, and we're talking about this angle in between. When we talk about a point that lies on the terminal side, we're saying that we have this point xy that's on the ray where the angle stopped. And from that point then we can drop a line down to our horizontal axis, and we can create a right triangle, which allows us to use right triangle trig. The distance from here to here can be determined with what should look like familiar, right? The distance formula. We end up with the square root of x squared plus y squared, and of course y can't be equal to 0. So as we talk about standard position, remember what that means. When we talk about a point that lies on the terminal side, we're just saying you're going to graph a point on that ray, and from that point you can make your triangle. The distance here to here is the radius, and we can get that by using our model. Okay, so let's talk reference angle. What we want to know about a reference angle is that by using a reference angle, we can actually determine with a smaller angle the value of some of those bigger angles. So when we talk about a reference angle, the original angle might go from here to here. The reference angle is this acute angle that forms right here from where the angle terminates and the horizontal x-axis. So we're talking about that little angle right there. So when we're talking about how do we find what that angle is, that reference angle, if it's in the first quadrant, it's an acute angle, and all those angles in that first quadrant technically can be reference angles. The definition of a reference angle is it's an acute angle that's formed between where the angle terminates and the horizontal x-axis. So that has to be acute. So that means in quadrant 1, everything is acute, so everything is technically a reference angle. Then when we move over here to quadrant 2, think about this. If I go from here all the way over here, I'm past 90 degrees all the way into this next angle. And so that's going to be an angle bigger than 90 degrees. If I find the reference angle right down here, the reference angle is going to have the same trig properties as this big angle over here. So instead of having to work with this obtuse angle, we can use the acute angle that's formed right here and be able to find the same answers. And so to get the reference angle when it's in the second quadrant, we take pi and we subtract the angle. So in other words, pi would take us all the way around, halfway around the circle. The angle would take us right here, and if I subtract those two things, then that's going to give me this little piece that's left in here, and that's what my reference angle is. So if you were in terms of degrees, you would say 180 minus theta to be able to get that reference angle. If you're in quadrant 3, we're already past pi, so we're already past the halfway mark, and we're going a little bit further down here. So then what we would do is if we know this full angle, we can take the angle, which goes all the way around to here, and we can subtract off pi, the top half of the circle, and that's going to leave us this little space in between. So again, if it were in degrees, you could say whatever the angle is minus 180 degrees. And finally, when we get into the fourth quadrant, for our reference angle, that's going to be, remember the angle goes all the way around to here, so that outside part is the angle. What we're looking for is this piece that's right in here in the middle between where it terminates and the horizontal x-axis. So in order to determine what that is, since I'm all the way almost around the circle at 2 pi, I'm just going to take 2 pi, which is the full rotation around, and I'm going to subtract the angle, which goes from here to here. And when I subtract all of this out here that's my angle, I'm left with this little piece of an angle right here, which is, again, going to be acute. So in quadrant 1, there's no subtracting because everything is an acute angle. In quadrant 2, we're going to take the halfway point, which in this case, pi minus the angle. When we're in quadrant 3, we're going to take the angle minus pi to get that. And when we're in quadrant 4, we're going to take the full rotation of 2 pi, then subtract off the angle, and that's going to give my reference angle in between. So again, definition of a reference angle. The reference angle is the angle in standard position that's acute and is formed by the terminal side of theta and the horizontal axis. All right. So when we have our triangle here, right, and we said this was R. Oops, excuse me there, guys. And we said this was R right here, and we're going to make a triangle. So when we drop that down, we have this triangle in here. This is the obtuse angle. This is the reference angle. And the distance, vertical distance is y, and the horizontal distance is x. So if I were going to plot that point, right, I would go out x units and up y units to get that point. Well, that's what our triangle is going to represent as well. So thinking back to SOHCAHTOA, we can find that sine of theta, which is opposite over hypotenuse, would technically be y over r. And then if we were doing cosine, then we would do adjacent over hypotenuse. That would be x over r. And then tangent would be opposite over adjacent, so y over x. And we do have to be mindful that we remember x can't be 0 because that would technically be in the denominator of the fraction. A radius is never going to be 0 or negative, so we're good there. And then we do the reciprocal. So we turn this upside down, so we get r over y. We turn this upside down, we get r over x. And we turn this upside down and get x over y. And again, all the denominators can't be 0 because we can't divide by 0. So what happens is when I find this ratio for this reference angle, that's going to be the exact same thing as if we were actually working with the big obtuse angle. It makes our numbers smaller and it allows us to work back and use those unit circle values in our special right triangles to determine these values. So now after we've kind of talked over some basics that are on that first page of the note sheet, now we're going to work through the problems that were on the small sheet at the very beginning. So the first problem says I have tan of theta, which is negative 5 over 4, and it's giving me a condition. So the condition is the cosine of theta is greater than 0, which means positive. And then it's asking me to find the sine of theta and secant of theta. And so what I'm going to do is kind of work through this process. I'm going to tell you what I would be thinking if I were working the problem, and hopefully we'll get to the same spot. All right then. So the first thing I need to do is figure out how this condition plays into what I'm trying to figure out. And so what I'm trying to do then is think about where do I plot these ratios to make a triangle where tangent is negative because that fraction is negative, but the cosine is positive. All right, so what I would just do is do my all students take calculus and think through that, right? So we're going to give the condition, we're going to determine the quadrant to draw this triangle in, and then we're going to use this triangle to figure out these two answers. Okay, so I'm thinking in my head, let's look at the first things first. They gave us tangent is negative. So I know tangent is negative in quadrant 2 and 4 because all students take calculus. It's positive here, so it has to be negative here and here. Then I look at the second piece of information they gave me where they said cosine is positive. Well, cosine is positive in quadrant 1 and 4, so that means these two won't work. So where I draw my triangle is the quadrant that works for both of those statements, and that has to be the last quadrant because here is C and C would be positive. So then I go to my quadrant. I'm going to draw a quadrant mark, and I'm going to draw the triangle and label all the sides that's in there. Okay, so it's in the fourth quadrant, so I drew my triangle in here. Remember that the right angle is always on the horizontal x-axis, so it's never at the origin and it's never on the y-axis. And so once I did that and I had my triangle in here, then I went back to my tangent, which is opposite over adjacent, and from this angle at the origin, the opposite side is here and the adjacent side is here. And we know from when we graph points in the fourth quadrant that we would have to have a positive value and then a negative value. So the negative is going to go on the negative 5 in my triangle. Well, we are missing the hypotenuse, so I can very quickly do my Pythagorean theorem and come up with the length of the hypotenuse. And once I have all of the sides labeled in my triangle, I should be able to figure out what sine of theta and secant of theta is. All right, so now this is what we're trying to find. So I'm just starting with keeping track of what the ratio of the trig function is. So the first one we'll do is sine, which is opposite over hypotenuse. And so when I actually put the values in, the opposite side is negative 5 and the hypotenuse is root 41. And we know that we don't leave that root 41 in the bottom, so I rationalize that out, which means that my final answer for sine of theta is negative 5 root 41 over 41. So once I have that, I'm halfway through the whole find part of this problem, and now I'm moving to secant. So secant, remember, is hypotenuse over adjacent. So I'm using that reciprocal ratio again. And then I go to my triangle and put the information in. So the hypotenuse was root 41, the adjacent was 4. This is a nice looking whole number, so we don't have to rationalize anything. And we have our answers for question 1. So it's real important when you have a problem that has this many pieces to it, make sure you've taken care of everything. To be able to draw the triangle, we had to look at that second condition, and once we had our triangle, we had to make sure all the sides were labeled. And then finally, once all the sides were labeled, we had to find both pieces that the question was asking for. So make sure that when you're finished, you double check that and you know that you've answered everything that the question has asked. So there's nothing worse than missing a question because you didn't actually double check and make sure you answered it. All right, question 2 says find the reference angles. Remember, that's the acute angle that's formed by where the angle terminates and the horizontal x-axis. And we're going to draw a picture. Okay, we like to draw pictures now, right? So 300 degrees, where would 300 degrees be? What quadrant? It would be in quadrant 4. So if I'm drawing my 300 degrees, that's this angle right here. The reference angle is right here. And how do we determine that mathematically when it's in the 4th quadrant? Well, we're in degrees, so 1 revolution around the circle would be 360 degrees, and then we're going to subtract the angle, which is 300. So when I am working that out, I'm going to get 360 degrees minus 300 degrees equals 60 degrees. The reference angle is 60 degrees. Now I get you can do that subtraction in your head, and that's fine. Just make sure for the purpose of working this out that you are identifying what that reference angle is. Okay? So then we're going to go on to problem 2, which is 200 degrees. So where would 200 degrees be? I know it's a little bit bigger than 180, not quite 270, so it's going to be in quadrant 3. So in quadrant 3, remember, it terminates here. The horizontal axis is here, so the reference angle is that theta right there in between. So when I'm in quadrant 2, I take the 200 degrees that is the angle, I subtract the top half of the circle, which is 180, and then I can get my reference angle, which in this case is going to be 20 degrees. Number C is, or letter C is negative 120 degrees. So negative, remember, means we're going clockwise, not counterclockwise. And we need to know where that's going to be. So I know it's going to be a little bit bigger than 90 degrees, but less than 180. And I am starting at 0 and working clockwise. So that means when I graph that, that's going to be in the 3rd quadrant. Now here I do need to be a little mindful of that negative sign on the angle, because remember, when I'm in quadrant 3, I take the angle and I subtract 180 degrees. So here I take my angle, which is negative 120, and I subtract negative 180, because remember, I'm subtracting this part off. And so what I'm actually doing is taking the angle and adding 180 degrees to it, and that gets me my 60 degrees, which is what my reference angle is. All right, and D. So I have negative 7 pi over 4. So this time it's in radians. So where would negative 7 pi over 4? It would be in the 1st quadrant, because remember, we're starting at 0 and we're working this way. So if we count it backwards, that would be 1, 2, 3, 4, 5, 6, 7 pi over 4 in the negative direction. And there is only one pi over 4 angle in the 1st quadrant that we can use. And so that means that our reference angle is pi over 4. So that one is an easy one. Even though we're going in the negative direction, we were still looking for this angle right here, which is the positive acute angle in the 1st quadrant. And there is only one pi over 4 angle there. So that becomes our reference angle. For number 3, we're evaluating without a calculator. And so we're going to go back and talk about that initial circle that we learned about when we first started talking about this, and we talked about quadrantal angles. A quadrantal angle means we moved 1 unit this way, which means the radius of that circle is equal to 1. So when we start here, this could be 0 or 2 pi, and then we would go up to, if it's 0, we would go up to pi over 2, then around to pi, down to 3 pi over 2, and finally back to 2 pi. So one thing to remember is I can have a 0 here that could be in radians. I could have a 0 there that could also be in degrees. And so then when I go up here at the top, I have pi over 2, and the coordinate for this would be 0, 1. And over here at pi, it would be negative 1, 0. And down here at pi would be 0, negative 1, and then brings me back to close my circle up at 1, 0 again. Well, the significance of those 2 points are those coordinate points are actually 2 of your trig functions. They are cosine theta and sine theta. So when you move horizontally, you're moving in a cosine direction, and then when you're moving up to that point, you're moving in a sine direction. So that means x equals cosine and y equals sine. And so that means right now, without knowing a whole lot of anything else, you know 2, 4, 6, 8 trig values without having to do any calculation. Okay, and so we're going to answer some questions and practice that. All right, so the first one is sine of pi. So pi is over here, and it's cosine sine, so sine is 0. Now we're going to cosine of pi over 2. Pi over 2 is up here. The coordinate is 0, 1. The coordinates represent cosine sine, so that means cosine of pi over 2 is 0. Nice and easy, right? Okay, so now I'm going to do tangent of pi over 2. Well, this is cosine and sine, which are not just cosine and sine, because tangent, it doesn't have like a coordinate for tangent, right? So when we're doing that, then we have to think about some of those ratios that we already know. This is where the quotient identities come into play. So we know that tan of theta equals sine of theta over cosine of theta. So we can use that when we're trying to determine tangent, because we can use the ratio of these two numbers here. And then we can also use the quotient cotan of theta, because we know that's cosine of theta, sine of theta. And so that's what's going to come into play as we're talking about the tangent value right now. So tangent of pi over 2 is up here, and tangent is sine over cosine, so we're going to take sine, which is 1, put it over cosine, which is 0. Whoops, you can see the problem there, right? Sine over cosine, 1 over 0, we can't divide by 0, so that makes this undefined. And that is the initial, are the initials, or the abbreviation I want you to use is UND for undefined. Okay, so let's do cotan. So we know that cotan is cosine over sine, so we go up here at pi, and we do cosine, which is negative 1, over sine, which is 0, and we end up with the very same situation again. Cosine over sine is negative 1 over 1, which means, again, we can't divide by 0. And then we're down here at secant, and so secant at pi over 2, well, how do we do that? What could we use for secant? Well, that's where those reciprocal identities come into play again. And so when I'm using the reciprocal identity, I'm doing secant of theta is 1 over cosine. So that's 1 over 0, because cosine at pi over 2 is 0. So I'm just using that value. And then I run into the same situation again. 1 divided by 0. We can't divide by 0. So there are going to be times where you're going to have undefined values. There are going to be times where you can actually find a value like we did on the first two. So pay close attention to your quotient and reciprocal rules and make sure you are good to go. All right, so on question 4, we are going to evaluate for sine, cosine, and tangent of a given angle. Again, no calculators, and drawing a picture is a must. So the angle I'm going to find is 750. So I have to figure out where 750 would be, because that's more than one rotation around the circle. So there's a couple ways you can do that. But it's going to end up in the first quadrant. So what I thought in my head was, well, 360 and 360 is 720. So that means it's one around the circle twice. And that means 720 plus what gives me 750, which has to be 30 degrees. So I was 30 degrees into this rotation, and that's where my 750 is. And so that means this angle right here is 30 degrees. Now, if you remember from your special right triangles, when you label your triangle, the 1 is always opposite the 30 degrees, so that's 1, that's 2, that's root 3. Those are those special right triangle rules that I expect you to have down by now. All right, so what we're going to do then is use 30 degrees to determine what 750 is. Okay, so the first one was sine of 750. Sine is opposite over hypotenuse, and I'm doing it of the acute triangle right here, so that's 1 over 2. That means sine of 30 degrees is the same thing as sine of 750 degrees. And then I'm going to do cotan or cosine of 750, and cosine is adjacent over hypotenuse. So in my 30-degree triangle, the adjacent side is root 3, the hypotenuse is 2. So my angle 750 also has the adjacent side of root 3 and the hypotenuse of 2. And then we go down to 750 for tangent of that, because remember we're finding these 3 values for each of these. So then when I go down here to tangent, I have in this 30-degree triangle, adjacent over opposite, or I'm sorry, opposite over adjacent. So the opposite in my 30-degree triangle is 1. The adjacent is root 3, so I get 1 over root 3. Or when I rationalize it, root 3 over 3. And that's the same thing. The 30 degrees is the same thing as the tangent of 750 degrees. So when you're doing a problem like that, the theta is 30 degrees. That's what's in here, which is my reference angle. We use our special right triangle to label those when we can. And then just a reminder that the side opposite 30 degrees always equals 1. And then we use the triangle to answer the question like we did here. Okay, so B is 4 pi over 3. And so we have to figure out where to draw 4 pi over 3. So the things that jump out to me is that 4 pi over 3 is a multiple of pi over 3, which means you're looking at a multiple of a 60-degree angle. And so it's going to look like this. So here's my reasoning and how I thought through it. 4 pi over 3 is a multiple of pi over 3. And so that means I'm looking at a reference angle of 60 degrees because pi over 3 is 60 degrees. And we talked about ways you could remember how those are connected together. So we're going to put our triangle in, and we had to figure out where that was going to go. So we're counting pi's over 3's, and we could count around until we got to the 4 pi over 3. That means this angle right in here has to be 60 degrees. So when I set up my 60-degree triangle, the side opposite 60 is root 3. The short side is 1, and it's 2. But remember, this is in quadrant 3. And in quadrant 3, when you graph a point, you do a negative, negative. So both of those lengths of those sides have to be negative. And that's one of those places where students miss points when they're doing assessments on that, is they forget that this is in the negative direction, this is in the negative direction. So I just wanted to remind you about that. Okay, so here we go. The first one was sine of 4 pi over 3. Sine is opposite over hypotenuse, so then it's negative root 3 over 2. And then we did cosine of 4 pi over 3. So in my 60 degree or pi over 3 triangle, I'm going to do adjacent, which would be negative 1 over hypotenuse, which is 2. And so the cosine of this 60 degree or pi over 3 angle is the same thing as the cosine of the 4 pi over 3 angle. And then finally tangent. So tangent is going to be in the triangle here, opposite over adjacent. So opposite over adjacent, negative root 3 over negative 1 makes it positive root 3. So things to remember when you're doing problems like this is to make sure your answer works with all students take calculus. Think about what's positive and what quadrants. That's always super important to think about. Don't forget the negative on the x and the y when labeling the triangle. This is one of those high missed things right here, so we just need to get in the habit of checking for that. And tangent of theta should be the only trig function positive in the third quadrant. So, we can use that. All students take calculus to kind of double check our answers and make sure that makes sense with what we know about behaviors in each quadrant. And part C on question 4 is negative 3 pi over 2. So remember, now we're talking about an angle going clockwise around the circle and at negative 3 pi over 2. So that puts this at the quadrant marker up here because we're going in the negative direction. And since it's on the quadrant, there's not an acute angle because that's actually on the axis, and in this case would be like 90 degrees if we're thinking about going from here to here. So we use that coordinate point 0, 1. 0 is the cosine value, 1 is the sine value of negative 3 pi over 2. Okay, so if I do sine, then that's going to be 1. If I do cosine, that's going to be 0. And if I do tangent, that's undefined, remember, because sine over cosine would be 1 over 0, and we can't divide by 0. Okay, so this one has no reference angle because it's not an acute angle. It's already 90 degrees. It is a quadrantal angle on the axis, so remember that you use that coordinate point that we talked about in the circle from earlier, last problem maybe. And then the coordinate points represent cosine theta, sine theta. And so we use that coordinate point to answer. So this is where people go, that's pretty easy, and they are correct. All right, that takes care of question 4. Last one, problem 5. In 5, we're going to evaluate based on information. So again, we're going to have to set up a picture and actually we're solving. So we're evaluating, getting answers, but we are solving. All right, so the last one, find the 2 solutions for the equation given your answer in degree and also in radians. So instead of giving you a whole bunch of other problems, we're just practicing both units at the same time. Very seldom on assessment questions will you have to do both, but I figured this is a good way to practice making sure we can handle either way. So the problem is sine of theta equals 1/2. So when you look at this problem, what's the unknown? What is it you don't know? You know the ratio of opposite over hypotenuse. You know that we're talking about the trig value sine, but we don't know the angle that we're trying to find, which means our answer, theta, is what we're trying to find, and that's going to be representing angles. Okay? So the first thing we need to know is how are we going to draw this, because we know, according to all students take calculus, that we have a trig function in 2 different quadrants that can be positive. Sine can be positive in 2 places. So it can be positive in the first quadrant because that's all. It can also be positive in the second quadrant because that's where the S is, which stands for sine. So we're going to draw a triangle in 2 quadrants, both 1 and 2, because of the all students take calculus. All right. So once we do that, we've got this triangle over here, and we have this triangle over here. So in quadrant 1, we're talking about the angle that goes from here to here. In quadrant 2, we're talking about the angle that goes from here all the way around to here. Okay? So what are the 2 angles that actually have a sine ratio that is the opposite over hypotenuse is 1/2? Well, so first off, we know that we're dealing with a 30-degree angle. Okay, because sine is opposite over hypotenuse, and that's √3 on the bottom then, and we know the angle opposite 1 is 30 degrees. So I'm going to go ahead and do it in degrees first because I know that's probably what you're the most comfortable with. Okay, so once we know this is 30 degrees, then we know the second angle is in quadrant 2. We know that we can find we have a reference angle of 30 degrees over here because we could take the 180 minus 30, and that would give us this angle right here. So that means that we should know what this angle is right here because we're really comfortable with working in degrees. So 180 minus 30 gives me a second angle of 150 degrees. And that means both of these angles given in the circle have the same ratio of 1 to 1/2. So now if we're dealing with it in radians, a 30-degree angle is pi over 6. So that's easy to calculate. And then I need to know the pi over 6 angle in the second quadrant. So the pi over 6 angle in the second quadrant is 5 pi over 6 minus pi is how we got that, right? All right, well, as I said that out loud, I caught my mistake, so I wanted to fix that. So let's backtrack just a minute. I don't know, I subtracted in the wrong order, but anyway. So when we're down here, we know that we have pi over 6 as our reference angle, because if this is 30, this is 30. If this is pi over 6, this is pi over 6. So when I'm in the second quadrant, I take pi minus pi over 6. I get a common denominator, so I get 6 pi over 6 minus pi over 6. 6 minus 1 is 5 pi over 6, which is the value of the quadrant in the second quarter in radian measures. So sorry about that, but that's what that's going to look like. All right, so we have the 2 answers here in degrees, and we have the 2 answers here in radians. So let's do this last problem. All right, so this time we're doing sine of theta is negative 1/2. So that means I need to know what 2 quadrants would have a sine value that's negative. And so we know it can't be in 1 and 2 because sine is positive in 1 and 2. So that means that sine is going to be negative in 3 and 4. So when I draw my picture, now I have an angle and a triangle labeled in quadrant 3 and quadrant 4. So I know again that sine is opposite over hypotenuse, which means this has to be a 30-degree angle because the 30 degrees is opposite the 1. I know when I label this that's negative that is opposite over hypotenuse, and I know hypotenuses can never be negative, so the negative has to go with the 1 on the downside. And then from there, I know this is my root 3 side, which has to be negative because I'm on the negative side. So then over here, it becomes positive root 3 because I'm on the positive side, still negative when it goes down, and then root 2. So now we're going to find the solution, and we're going to find this angle from here to here, and this angle from here all the way around to here for my solution. So the first one I get is 210. So how did I get that? Well, I'm in the third quadrant. So what I did this time is I took the 180 and I added the 30 degrees to it, and that gave me 210. So that, since I didn't know the angle, I'm trying to find the angle, I had to come up with a little bit different route, and I did that by saying halfway around the circle is 180 plus the reference angle, which is 30 degrees. And now I need to go all the way around here. So I know the reference angle is 30 degrees, so I can take 360 minus 30 degrees, and that's going to give me that's going to give me 330 degrees. So now I have my two angles that are in degree form, and so now what I'm thinking is I know that 30 degrees is a pi over 6, so I want the multiples of pi over 6 that are in the third and fourth quadrants. So the pi over 6 angle in quadrant 3 is 7 pi over 6, and the pi over 6 angle that's in quadrant 4 is 11 pi over 6. So that's kind of how I reason through those. So this takes and gives you a couple of ideas of solving. We looked at some reference angles and kind of looked at a few new concepts. And so now you're going to do your practice and do your daily practice on Canvas. So you can do some individual practice and make sure you've got these concepts. Be sure to come ready with questions next time. If there's anything you want to ask, as always, you can come into advisory time or tutorial time to get help. Please stay on top of things, learn things as we go, make sure you're getting it. Makes life so much easier. Your life is less stressful in the process, and you get a good trig foundation. Thanks, guys.